Lesson 3, topic solving systems by elimination, part 1. Learning target, I can solve a linear system using elimination. So just some key vocabulary words. System of linear equations is two or more linear equations graphed on the same coordinate plane. A solution is where those lines intersect, or the coordinate point that makes both equations true. Substitution we worked on last class, which is replacing a variable with its equal value. Elimination is to get rid of through addition or subtraction. We eliminate something, we get rid of it, we make it equal 0. Opposites are two numbers the same distance from 0. Now, the piece of opposites that's important for this lesson is that opposites, like -4 and +4, if we add them together, they make 0, or they are eliminated. So if we combine two opposites, we eliminate that value. Quick check, what would be the solution to this linear system? Answer in Edpuzzle. So we are going to solve the following systems using elimination. So elimination, this method means we are going to add up our two equations. So we're going to treat this like one big addition problem. And when this happens, we are going to eliminate something. So today's our part, everything is already set up for elimination. And then part 2, which we will do next class, we will work on setting it up to make it work for elimination. So if you look here, we see opposites, 2x and -2x. +2 and -2, those are opposites. And that's what we're looking for with elimination. We're looking for opposites with one of our variables. So in this case, our variable x is going to be eliminated because 2 plus -2 is 0. That means we get rid of our x's. They're gone. They are eliminated. Now I continue the problem. 3y plus 5y is 8y equals 11 plus 13 is 24. So I have 8y equals 24. And now I just need to finish solving that equation for y. 8y is 8 times y, so I'm going to undo that with division. Divide by 8 on both sides. Y equals 24 divided by 8 is 3. So I know y equals 3. Now we are not done because our answer is a coordinate point, and a coordinate has an x value and a y value. Right now my y value is 3. I need to figure out my x value. So that's when I'm going to go up to the top and I'm going to choose either equation 1 or equation 2. It does not matter which one you choose. I'm going to choose equation 1 because it has all positive values. 2x plus 3y equals 11. And then I can make that substitution. I know y is equal to 3, so I can replace y with 3. I make that substitution by replacing y with 3, and now I can solve this equation. I would like you to solve this equation and tell me what x equals. After solving the equation, you should have got x equals 1, so we put that up in our coordinate point, and our answer would be 1, 3. That would be the point that those two lines cross. All right, let's try another example. So again, we're going to treat this like one big addition problem, and we should see opposites. This time I see opposites in not my x variables, but my y variables. I have -3 and +3. Those are opposites. So in this case, my y values are going to be eliminated. They make 0. -3 plus 3 is 0. So then I have 4x plus 5x is 9x. Equals 2 take away 2, or 2 plus -2 is 0. 9x equals 0, so I have to get x all by itself. Divide by 9, divide by 9. X equals 0. So for my coordinate point, I know my x value. X is 0. I need to solve for y. To solve for y, you just pick any equation. You pick top or bottom. I'm going to pick the bottom one. Again, it doesn't matter which one you choose. 5x plus 3y equals -2. I know what x is. I can make that substitution. I replace x with 0. And now I can solve this equation. 5 times 0 is 0. So that is eliminated. We have 3y equals -2. divide both sides by 3, and we get y equals negative 2/3. You can also do that division and you'll get a decimal. You'll get 0.6 repeating, with 666 going on forever. Your calculator will truncate it and give you that 7 there at the end. So either answer is okay. I'm going to use the fraction negative 2/3. Sometimes you will get decimals or fractions, and that's okay. That doesn't mean you did anything wrong. That's just sometimes how the math works out. All right, we have 2 more examples, and this time we're going to talk about special cases. So special cases are those parallel lines that have no solution, and that infinite case where they are the same line, so they have the same solution. So they have infinitely many solutions. So that looks different when we're not graphing, when we're solving it algebraically. So I want to show you what that looks like when we solve it algebraically. So when I add up these 2 equations here, I have x minus x, or 1x minus 1x. And that makes 0. I don't have any x's left. And then here I have negative 2y plus 2y. Well, negative 2 plus 2 is also 0. So I have 0 plus 0 equals 13 plus 5 is 18. 0 plus 0 is 0. 0 equals 18. Now in this case we have no variables left over. When this happens, when you do not have a variable anymore, you have to ask yourself, is this equation true or false? Does 0 equal 18? Nope, it's false. If we say false, that means there's going to be no solution. That means those lines are parallel and they are never, ever, ever going to cross. So let's try one more example. We have negative 3x plus 3x. So right here you can see we have opposites. So they eliminate, they're 0. 8y plus negative 8y. Again, those are also opposites. They eliminate, they make 0. Equals 27 plus negative 27, or 27 minus 27. That is also 0. So here we have 0 equals 0. Again, no variables are left over. We have just 2 numbers. So we ask ourselves, is this true or false? Does 0 equal 0? Yes, it does. It is true. And that means there are going to be infinite solutions because those 2 equations graph the same line. That's all your notes. Go ahead and move into your practice.